Hi, so I'm going to finish the section with a generalization to variation of parameters. We did it for second order ODE, so let's do it for nth order linear ODE. So we are given an ODE, a linear ODE, an nth order linear ODE of the form yn plus an minus 1 of x yn minus 1 plus a1 of x y prime plus a0 of x y equal f of x. And notice that the coefficient of y sub y, the nth derivative of y, is 1. Okay, if it's not 1, you have to divide by it. Okay, to get an ODE of this form. And I have here a0, a1 up to an minus 1, and f are continuous in some interval I. Okay, let y1, y2 up to yn be n linearly independent, they should be linearly independent solution to the ODE, to the homogeneous ODE L of y equal yn plus a1 of x y prime plus a0 of x y equal to 0. So I found n solution to the ODE L of y equals 0. Remember, I want to solve L of y equal f of x. Okay, we find a particular, it's enough to find one particular solution, a particular solution y sub p to, well, such that L of y sub p equal f of x of the form y sub p equal u1 of x y1 plus u2 of x y2 plus un of x y sub n with u1 prime, u2 prime, un prime solution, the unique solution to the system. So I will write the system in matrix form so that you remember it. So you write the matrix of the Wronskian. Yeah. So remember, the Wronskian is a determinant of some matrix, which is the matrix y1, y2 up to y sub n, y1 prime, y2 prime up to y sub n prime, and y1 n minus 1, y2 n minus 1 up to y sub n minus 1. And I multiply this. This is known because y1 up to yn are known, so this matrix I know what it is, and times what? u1 prime, u2 prime, u3 prime up to u sub n prime, and all this should be equal to 0, 0, 0, but except last one is f of x. So this means, why this has a unique solution? Because the determinant of this matrix is the Wronskian, which is different than 0, since y1 up to yn are linearly independent. Now if I want to write it in linear form, so this is y1 u1 prime plus y2 u2 prime plus yn un prime equal to 0, y1 prime u1 prime plus y2 prime u2 prime plus yn prime un prime equal to 0, and I go up to n minus 2 u1 prime plus y2 n minus 2 u2 prime plus yn n minus 2 un prime equal to 0. This is, I need n equation. This is so far n minus 1 equation, and the last equation is y1 n minus 1 u1 prime plus y2 n minus 1 u2 prime plus y sub n minus 1 u sub n prime, and this should be equal to f of x. The last equation is f of x. Okay, I find y1, y prime, and then I deduce one of the y1, y2 up to yn. Okay. Now let's, so before doing an example, let's recall the following. Recall trigonometric integration. So what's the integral of sine x dx? Integral is minus cosine x plus constant. What's the integral of cosine x dx? This is minus sine x plus constant. What about the integral of tangent x dx? Well, this is integral of sine x over cosine x dx. Notice that the derivative of cosine is minus sine, so this is like minus u prime over u. So this is minus log absolute value of cosine x, absolute value, minus log absolute value of cosine x plus c. Now, what about integral of secant x dx? Okay, and now you know this formula, it's in your book, but I mean, I'm not sure if you saw how to compute this integral. So I'm going to give us this small review of how to calculate the integral of secant x. Recall that secant x is 1 over cosine x. So the integral of 1 over cosine x dx is the same as integral, multiply the numerator and the denominator by cosine x, of cosine x over cosine square x dx. But now cosine square is nothing but 1 minus sine square x dx. Now notice that if I take u to be sine x, du will be cosine x dx. So this thing is equal, cosine x dx is du, so du over 1 minus u squared, which is integral du over 1 minus u times 1 plus u. And now I take 1 over 1 minus u over 1 plus u, partial fraction. This is a over 1 minus u plus b over 1 plus u. And now I cross multiply the denominator here, and you get 1 equal a times 1 plus u plus b into 1 minus u. Now taking u to be 1, you got that a equal to half. And taking u to be minus 1, you get b equal to half also. So this implies that integral du over 1 minus u times 1 plus u equal integral half over 1 plus u plus half over 1 minus u du. And this is equal, like when I integrate, half of log absolute value of 1 plus u minus half log of absolute value 1 minus u, which is equal half log absolute value of 1 plus u over 1 minus u. But remember, and then I have plus constant if you want. Yes, plus constant, plus constant. But now remember that u is nothing but sine x. So this is half log of 1 plus sine x over 1 minus sine x plus c. And this is equal half multiplied by the conjugate in the denominator. You will get log of absolute value 1 plus sine x square over 1 minus sine x times 1 plus sine x plus c. And this is equal half log 1 plus sine x square over 1 minus sine square x plus c. And this is equal half log 1 minus sine square is cosine square. So I can write this as 1 plus sine x over 1 minus sine over half of log 1 plus sine x over cosine x, the whole thing squared, plus c. And this is equal, now note, well, this is equal half, well, the square, the two go outside, so this is log of 1 plus sine x over cosine x plus c. And this is equal log of 1 over cosine x plus sine x over cosine x plus c, concluding that integral of secant x dx is equal log of absolute value of secant x plus tangent x plus c. Well, this is a formula. Of course, you can use it, but I mean, now you have to see it at least once in your math courses how to calculate this integral. Okay, now exercise. Solve the following ODE: y triple prime minus y prime equal tangent x, where x is between minus pi over 2 to pi over 2. Remember, I want everything to be continuous, and tangent x is continuous, I mean, except at minus k pi over 2. Well, minus pi over 2 and minus pi over 2 plus k pi, or pi over 2 plus k pi. And we can then plug in y of 0 equal 1, y prime of 0 equal 0. Let me just remember the initial condition. I wrote them somewhere here. Sorry about that. Y of 0 minus 1 and 1 equals 0. Y prime of 0 equal minus 1 and y double prime of 0 equal to 1. It's a full exercise, a bit long, but standard. So step 1, I solve y triple prime minus y prime equal to 0. Now this is linear homogeneous with constant coefficient. So y equal e to the mx is a solution. F and, well, to L of y equal to 0. F and only f. What is L of y here? Just so that I'm precise. Y triple prime minus y prime. F and only f. M. Solve the auxiliary equation m cube minus m equal to 0. Well, sorry, I want to solve this equation plus, otherwise it's different exercise. Plus, sorry, let's make it more interesting. So this is m times m squared plus 1 equal to 0. So m equal to 0 is a real simple root. So it gives me the solution y1 equal e to the 0 x, which is 1. M equal plus or minus I are complex conjugate simple roots. So they give me two solutions: y2 equal cosine x times e to the 0 x, and y3 equals sine x times e to the 0 x, which is 1. Then the homogeneous solution y sub c is c1 times 1 plus c2 cosine x plus c3 sine x. Now step 2, I find particular solution y sub p to L of y equal y triple prime plus y prime equal tangent x of the form y sub p equal u1 y1 plus u2 y2 plus u3 y3. Now, although this is constant coefficient, I cannot use undetermined coefficient here because f of x is tangent x. It's none of the form in the table. Let me tell you that the method of variation of parameter work always. Okay? The undetermined coefficient work only on specific cases, but even there you can use variation of parameters. But the undetermined coefficient is somehow shorter when you can use it, okay? Whenever you can use it. But this is u1, y1 is 1, plus u2 cosine x plus u3 sine x with u1 prime, u2 prime, u3 prime solution to the system u1 prime y1 plus u2 prime y2 plus u3 prime y3 equal to 0. We need three unknown, u1 prime, u2 prime, u3 prime. So three equation. u1 prime y1 prime plus u2 prime y2 prime plus u3 prime y3 prime equal to 0. u1 prime y1 second, u2 prime y2 second plus u3 prime y3 second. This is the third equation. So here I put f of x, the last equation. So now let's plug in your y1. So this is 1 times u1 prime plus u2 prime, so cosine x u2 prime plus sine x u3 prime equal to 0. Now what's the derivative? Remember, y1 is 1, y2 is cosine, and y3 is sine. So 0 plus, so I have minus sine x u2 prime plus cosine x u3 prime equal to 0. Now differentiate again, you get minus cosine x u2 prime plus minus sine x u3 prime equal to f of x, which is tangent x. And this is 1, 2, and 3. Now notice that if I do 1 plus 3, I get u1 prime equal tangent x, which is equal sine x over cosine x. So this is my first solution. So u1 is integral of tan x, which is equal log of absolute value minus log, what did I said here in that derivative? I hope I didn't make a mistake. Minus log. It's minus log of absolute value of cosine x plus c, but I choose the c to be 0 because I need one of the y1, one of the u1. I need only one particular solution again. So I need one u1 and one u2 and one u3. Okay, so I found one. Now multiply 2 by cosine x and multiply 3 by sine x and subtract. What do you get? So you get minus sine x cosine x plus cosine square x u3 prime. Here you have u2 prime and here u3 prime equals 0. And here minus sine x cosine x u2 prime plus sine square x u3 prime. I multiply by sine x tangent x equal tangent x sine x, and then you subtract. So I multiply by sine, so this is minus sine square x. Okay, and then you subtract, so you get, let me check. So I multiply this by cosine, this is correct. I multiply this by sine, this is correct. Okay, and when you subtract, you get cosine square of x plus sine square of x u3 prime equal minus tangent x sine x. But this is equal to 1. So u3 prime equal minus tangent x into sine x, which is equal minus sine square x over cosine x. And this is u3 prime. So what is u3? So it's implied that u sub 3 is equal minus integral sine square x over cosine x dx. So if you take u, so this is u3 equal minus 1 minus cosine square of x over cosine x dx, and u3 is minus 1 over cosine x minus cosine x dx. So u3 equal integral cosine x minus secant x dx. So u3 is sine x minus log absolute value of secant x plus tangent x plus c. And this is, I got this integral from here. Okay. So this is u3. I still have u2 prime. Okay, you see this exercise not that short. So I use 2. So using 2, I have minus sine x times minus sine x times, well, u2 prime plus cosine x times u3 prime. What is u3 prime? is minus sine square, so this is minus sine square of x over cosine x is equal to, let's check this equation, 2 is equal to 0. So you get minus sine x u2 prime minus sine square of x equal to 0. So u2 prime is equal sine square of x and minus sine x here. So u2 prime equal minus sine x. So if u2 prime equal minus sine x, this implies that u2 is equal, well, the c here, I don't need it. So u2 is cosine x plus a constant, and I don't need a constant. Now I have all the terms, so y sub p is u1 y1 plus u2 y2 plus u3 y3, and then this gives me yp equal u1, which is what? Minus log absolute value of cosine x. So minus log absolute value of cosine x times y1, which is 1, plus u2, which is cosine x, times y2, which was cosine x, I guess, yes? y2 is cosine x. So this is cosine x. And then plus u3, which is sine x, minus log absolute value of secant x plus tangent x, and all this times sine x. And y sub p, now notice that x is between minus pi over 2 and pi over 2. So this implies that tangent x, well, this implies that cosine x is positive. What about secant x plus tangent x? Now this is here, it comes in hand. So secant x is what? Is 1 over cosine x plus sine x over cosine x. And this is equal 1 plus sine x over cosine x. The numerator is always positive because sine is between minus 1 and 1. And the cosine x is positive. So this is positive. So it means the absolute value of cosine x is equal cosine x. And the absolute value of secant x plus tangent x is equal to secant x plus tangent x. So I'm doing it in the very detailed here. So y sub p equal. Notice here I have cosine square, here I have sine square. So I will have 1 minus log cosine x minus log secant x plus tangent x, and this whole thing times sine x. Okay, and then conclusion, y is equal y sub c plus y sub p. So y is equal c sub 1 plus c2 cosine x plus c3 sine x plus 1 minus log cosine x minus log secant x plus tan x sine x. Sorry. But notice that c1 plus 1 is now another constant. So you can write this, if you want to simplify, as y equals c1 plus 1 is just another constant c sub 1 plus c sub 2 cosine x plus c sub 3 sine x minus log cosine x and minus log secant x plus tangent x into sine x. And this is my solution. Now I have the initial condition that tell me y of 0. You see, it's a lot of work. I'm insisting on doing it this so that you know that you should. So y of 0 equal to 0. I have y prime of 0 equal to minus 1 and y double prime of 0 equal to 1, just to get used to trigonometric. So y of 0 equal to 0 gives me c1. So let me just write it, c1 plus c2. Now sine 0 is 0, cosine 0 is 1, so this is 0. Sine 0 is 0, so this is c1 plus c2 equal to 0. This is the first one. What about y prime of x? So y prime of x is is minus C2 sine x plus C3 cosine x. Now minus log, the derivative of log cosine x is tangent x, okay, plus cosine x times the log of secant x plus 10x. Minus, this is minus cosine x here, plus the log of secant x. Now minus sine x times the integral of log secant plus tangent, which I know is secant x. Correct? Because I know the integral of secant is this thing. So this means y prime, so this is what? So y prime of x is y prime of 0 is equal, now this will cancel, C3 cosine x, okay, this will be good. Tangent x, tangent 0 is 0, minus cosine 0, which is 1, times log of secant x, which is secant 0, which is 1, plus tangent 0, so plus 0, plus sine 0, so this is 0, and this is equal to 0. So I got that C3 is 0. Now I need y double prime, y prime of 0 is minus 1. Thanks God. So C3 is minus 1. Now I need y double prime of x. So I differentiate this again. We get minus C2 cosine x plus C3 sine x minus C3 sine x plus the derivative of tangent x plus 1 over cosine square x minus, now the derivative of cosine x is what? Is sine x log of secant x plus tangent x minus cosine x times the derivative of log secant plus cosecant, which is secant x. Okay. Now what is sine x? Secant x is nothing but sine x 1 over cosine x, which is tangent x. This thing is tangent x, and its derivative is minus 1 over cosine square x. So these two really can cancel out. Okay, I could cancel them. So this is not really here. So y double prime of 0 is minus C2. C3 is this multiplied by 0. And sine x, sine 0 is 0. So I have minus C2. I still have minus cosine x secant x, but this is cosine x over cosine x, which is equal to 1. So minus C2 minus 1. And this is equal to 1. So minus C2. So, C2 equal negative 2. So I have the system C1 plus C2 equal to 0, C2 equal minus 2, C3 equal to minus 1, and this implies that C1 equal to 2. And therefore, y of x is equal, now my big C1 is 2, so this is 2 plus C2 minus 2 cosine x minus sine x minus log cosine x minus log secant x plus tangent x into sine x. And this is my solution. Long calculation, but it's always the same thing, okay? So practice now, we can finish this section in the book. Thank you. That's the end of section 4.6.